Hello everyone and welcome back to the channel. Today we will be solving Amphibian escape, in which we have a robot frog which needs to climb out of a well quickly. The well has a height of h units and the well has a slippery factor denoted by B. A is the jumping power of the frog. So how does it works? First the frog jumps A units upwards, and then if it has not exited the well yet, it comes down by B units. Okay, and then it again tries to jump up A units and again B units down. You need to count the number of pairs A comma B such that if the frog had a jumping power of A and wall slipperiness is B, frog can escape the well within k seconds. Okay, I'll explain this using the second test case. 544. So over here n, no, not n, this is acha, n is the bounds of a and b. That means a and b needs to be in between 1 and n. Okay, sorry, then k is given 4 and h is given 4. So you need to find the number of pairs that you can select of a comma b such that if the frog jumps, it should get out of the wall in at most k number of moves. Okay, so what is the formula for such kind of questions? If the frog can jump up by A units and then it comes down by B units, then the net distance moved becomes A minus B. Okay, and since we need the frog to get out by at most the kth move, so it would be k minus 1 operations of jumping up and coming down and then just going up. This equation which you have should be more than or equal to h. All the values of a and b which satisfy this equation is the answer of this question. It basically means for k minus 1 moves, the frog will jump up and might come down, and at the kth move, it will jump out. So, the total distance traveled by the frog is a minus b into k minus 1 plus a. And this equation should be more than or equal to h. Okay? So, we need to solve this equation further. The equation is net distance into k minus 1 operations plus a needs to be more than or equals to h. Cross multiply this, you will get something like this, plus a more than equals to h, a get cancelled, so I can get b 1 minus k more than equals to h minus ka. So which gives us b is more than or equals to h minus ka upon 1 minus k. Now this value will be in negative. So we need to reverse the inequality. So it turns out b is less than equal to ka minus h upon k minus 1. I just multiplied this equation by minus 1 to reverse the polarity. Okay, so we have found this equation b is less than equal to ka minus h divided by k minus 1. So if I am iterating a from 1 to n and in between a is equals to I, so I will substitute the value of a in this equation and I will find the value of b. B is suppose less than or equal to some value x. Then 1, 2, 3 dot 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 to x will be the possible values of b which satisfy this equation. Okay, now this equation has one condition, that a is more than equal to B. But if you see in the question, there are cases where B is more than A. Now, what are the cases in which B is more than A? If B is more than A, for K minus 1 operations, the frog will stay on the ground itself because it is coming down more than it is jumping. So only one single jump of A will lead the frog out of the well. When A is when A is more than B, only one possible case exists, that A is more than or equals to H. Because when A is less than or equal to B, it does not move the floor for all the K minus 1 operations. Just for the last operation, it will directly come out of the well. Okay. So if we have a condition, like this, where the value of A is more than H, then that means over there we can directly add all the possible values of B as our answer, because if I can directly jump out of the well with A more than H, that means no matter what the value of B is, I can directly jump out, right? So now I will explain how do we implement this. Okay, this is iterating A from 1 to n. If the value of A is more than H, then all the possible values of B are accepted. Else, this is the equation which we just made over here. K into I minus H divided by K minus 1. Exactly the equation. Then if this equation min goes in negative, then there are no possible values of B for this value of A. So we don't do anything. Else we add min. Why do we add min? Because if this value comes out to be, let's say, 2, then the possible values of B are 1 and 2. If the answer of this equation comes as x, then all the values between 1, 2, 3, 4, 5, 6 to x are possible values of B. So we directly added all of the possible values of B we got from this equation, and directly we print the final answer. Okay, so thank you guys for watching. Make sure to like and subscribe to never miss another tutorial.